Hi guys, welcome to a new video on differentiation, paper 2 questions under math studies. This video deals with level 3 questions, and the two questions here focus on parallel lines. I shall solve the first question shortly. I shall now attempt to solve paper 2, May 2010, time zone 1, question 3. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given this function right there, and in A you are required to write down the values of x where the graph of f intersects the x-axis. So I've written down the equation on the calculator. I've adjusted my window as follows, and there is your graph. I want to find the points of intersection with the x-axis, so there is a function for that, which is second trace 0. The 0 function helps you find intersection points with the x-axis. So the first point is right there. I need to provide a left bound and a right bound and a guess. So the first 0 exists at negative 1.099 or just negative 1.10, negative 1.10. This is the 3 significant figure equivalent of this number. Next, I shall repeat the process for the other intercepts. So 0, left bound, right bound, and guess. So the second 0 lies at x equals 0.218. Finally, the third 0 shall be obtained as 3.13. So these are the three values of x where the graph intersects the x-axis. Negative 1.10 and 3.13 and 0.218. These are your three values. Next, I'm required to write down f dash of x. There is your original function in black, and there is the derivative function in red. Next, I'm required to find the value of the local maximum of y equals f of x. I do so by setting f dash of x to 0, because at the maximum point the slope is 0, or f dash is 0. Hence I solve this red equation which I obtained in B, equaling it to 0. This is some simplification. I've divided all the numbers by 6, and then I have factorized. So the two x values are 2 and negative half. From the sketch of the curve, we know that the maximum point exists at a negative x value. Hence, the value that I shall choose is x equals negative half. If I want to get the actual value of the local maximum, watch out, because in the question they did not request the x that makes the function maximum. They've requested the value of the local maximum, so that's the y value. So I can use the GDC to get that simply by second trace value and insert negative half and the y value is 6.25. So this is the maximum value of the function, and there is your answer. In question D, I am told that P is the point where the graph intersects the y-axis, and I want to write the coordinates of P and find the gradient of the curve at P. So since it intersects the y-axis, I should know that x is 0. Hence, if I plug 0 into each of these x's, what remains is the 3, this term, so y equals 3. Hence, the point is 0, 3. If I want to get the gradient at P, I simply need to find the value of f dash when x equals 0. So again, I plug 0 into f dash, so 0, 0, and I get negative 12. Hence, the gradient is negative 12. Of course, there is a way using the calculator to do this also. So let's take a look. So if I want to get the y value when x is 0, I press second trace value 0, and the calculator tells me that y is 3, which is what we got using the manual approach. If I want to get the gradient, I press second trace dy by dx, and I enter 0, and the calculator tells me that the slope when x is 0 is negative 12. Next, I'm required to find the equation of L, which is the tangent to the graph of f of x at P. So to get the equation of the tangent, we need a point and the slope. We know that the slope at P is negative 12 and that the point is 0, 3. So we plug these values into the point slope formula and we simplify and take the 3 to the other side, obtaining this final form of the equation: y equals negative 12x plus 3. We are then told that there is a second point Q on the curve at which the tangent is parallel to L, this line, and we are required to write down the gradient of the tangent at Q and then calculate the x coordinate of Q. So obviously in G this is pretty simple. The gradient of the tangent shall be the same as the gradient of L because they are parallel. Hence the gradient of the tangent at Q is negative 12, similar to the gradient of L because they are parallel. Next, I want to find the x coordinate of Q, and I do so using the information I obtained in G, which is the fact that the gradient is negative 12. Hence, f dash of x equals negative 12. So I equate this function to negative 12 and I attempt to solve this equation. So 12x squared minus 18x equals 0. I simply took this negative 12 to the other side as positive 12, so they cancelled out. Next, I've divided both terms by 6, obtaining this equation, and then I factorized, and I found that x is either 3 over 2 or 0. So there are two values of x for which the gradient is negative 12, either 3 over 2 or 0. And we know that the gradient is negative 12 when x is 0 at P. So obviously the gradient shall be negative 12 when x is 3 over 2 at Q. Hence the value of x at Q is 3 over 2. So this concludes our question. Take a minute to write the answer down if you will. I hope you have found this useful. I shall now attempt to solve paper 2, November 2008, question 5. Kindly take a minute and attempt to solve. The answer shall follow through shortly. So in question AI, you are asked to write down the value of y when x is 2, given this equation right there. So I've written the equation down on the calculator. Next I shall adjust my window for your reference, and then I shall click on trace. There is my function. So we want the value of y when x is 2, so we press second, trace, value 2, and the calculator tells us that when x equals 2, y equals 0. So this is the answer to AI. Double I requires that we write down the coordinates of the point where the curve intercepts the y-axis. You can do this either on the GDC or manually. You should know that the y-axis is where the x equals 0. So I just need to either use the GDC or substitute x with 0 in this equation. And of course any term with x equals 0 shall be cancelled. So I cancel this term and this term and this term, and what remains is the negative 2. Hence the coordinates of the point are 0 and negative 2. There are the answers to AI and AII. So moving on. I am required to sketch the curve for negative 4 less than x less than 3 and negative 10 less than y less than 10, indicating the information found in A. So I'm going to adjust my window to match the information that they've mentioned in the question. Negative 4 less than x less than 3 and negative 10 less than y less than 10. And I shall click on trace. There is my curve. I need to sketch this curve as it is, and I need to indicate the information that I found in A. So in AI we found that when x is 2, y is 0. So you must indicate that at this point x equals 2 and y equals 0. And the coordinates of the point where the curve intersects the y-axis, which is right there, and we have already found this to be 0, negative 2. So you need to indicate the coordinates of these 2 points indicated by the 2 arrows on the GDC in red. In question C, I'm required to find dy by dx. So I simply differentiate this black function right there, obtaining the function in blue right there. This is the derivative function. In question D, I am told let L1 be the tangent to the curve at x equals 2, and let L2 be a tangent to the curve parallel to L1. Show that the gradient of L1 is 12. So show that the gradient at x equals 2 is 12, and there is a calculator function to do that. So I press second, trace, find dy by dx, and I enter the given x value, which is 2, and the calculator calculates the slope for me, and the slope is 12. However, this is if the question was a find the gradient question. However, since the question is a show that question, you need to show the examiner that you understand that in order to find this 12, I shall need to substitute the 2 into the dy by dx function. So I shall substitute 2 into this blue function right there. obtaining this purple expression, and if I evaluate this I shall get 12. So I am required in double I to find the x coordinate of the point at which L2 and the curve meet. I am told that L1 and L2 are tangents to the curve. I am given that L1 is a tangent at x equals 2 and that L2 is parallel to L1. So since it is parallel to L1, then I know that L2 also has a gradient of 12 because parallel lines have equal slopes or equal gradients. So I need to find a point on the curve where the gradient is 12. And we know that I should find 2 points where the gradient is 12 because L1 has a gradient of 12 and L2 as well has a gradient of 12. So we need to equate the equation of the gradient to 12. We need to equate dy by dx to 12 and find the points that satisfy this equation. So I've equated the expression of the slope to 12. So 3x squared plus 3x minus 6 equals 12. And I have simplified and solved. You can do this using factorization or the GDC. And I found that the x coordinates that satisfy this equation are -3 and 2. Since I already know that L1 is tangent at x equals 2, hence I deduce that L2 is tangent at x equals -3. So this is the solution to D double I. Next, we are asked in triple I to sketch and label L1 and L2 on the diagram drawn in B. Here is the calculator sketch for reference. There is your L1 tangent to the curve, and there is your L2 also a tangent to the curve at x equals -3. And you will notice that the two tangents are parallel as indicated in the question. So for question E, you are told that dy by dx is greater than 0 for x less than -2 and x greater than b, where b is positive. Using your GDC, find the value of b. So dy by dx greater than 0 means that the slope is positive, hence the function is increasing. So we want to know where the function is increasing. So if we look at the curve, we will notice that the function is increasing in this area before the maximum point, and then also increasing after the minimum point. So starting the minimum point and on, the function is increasing. So if I want to know the value of b, then I want to know the value of the minimum point, because starting there the function shall be increasing and hence the slope shall be positive. So second trace minimum, left bound, right bound, guess. So I am told that the minimum exists at 0.999 or just at 1. Hence the value of b is 1. So there is your answer to EI. The value of b is 1. In double I, I'm required to describe the behavior from -2 to x to b, and using the GDC, I will notice that from -2 up until b, the behavior of the function is decreasing. The function is decreasing from -2 to b, or from -2 to 1. The equation of the tangent to the curve at x equals -2 is found as follows. Since I need the equation at x equals -2, then I need a point and the slope. So first we shall attempt to get the point, and this is found using the GDC. So second value when x equals negative 2, the value of y is 8. Hence, my point is negative 2 and 8. I also need the slope when x equals negative 2. So again, second, find the slope negative 2, and the calculator tells me that the slope is 10 to the power of negative 6. Of course, 10 to the power of negative 6 is 0.00001, which means that the slope is 0. Whenever you find such a small number on the calculator, you understand that this is a machine error. It has to do with the mechanics of the GDC. So you just assume that the calculator means that the slope is 0. Hence, at x equals negative 2, we have determined that y equals 8 and the slope is 0. We substitute into the point slope formula. So y minus 8 equals 0 times x plus 2. Of course, 0 times anything is 0, so y minus 8 equals 0, and hence y equals 8. So take a minute to write the answers down if you will. This concludes our question. I hope you have found this useful.